Welcome to the next video on more factoring fun. Last video we gave you some basic rules into how things are multiplied and how things are going to be breaking apart through factoring. And we're going to continue that concept and add an extra little rule in there. So the first thing, not rule, but more of a guideline, okay? I will tell you this, the guidelines that I gave you are things that I find easy for me. There are some other ways of doing things, and different teachers will tell you different ways. I like this because it's very systematic, and there's not much guesswork involved. So let's just go through it. The very first thing I tell you to do is factor out the GCF. That's the first thing you want to do. When you get a long expression, find the greatest common factor and pull it out. The next thing is to check what's remaining for any special product rules. And when you do, you can factor it out that way by following the special product rule and working backwards. The next step that I have up on your paper, it says this: check for group factors. All right, now I will tell you this, that is a Mr. Lewis terminology. The correct way of saying it is you're going to factor by grouping. So what does that mean? Remember in the last video we found the GCF of an expression, and when we did, we couldn't take it any farther. Well, sometimes that's going to happen, but other times you might be able to take that expression and break it apart even farther, even though it doesn't follow a special product rule. And there's ways that we do that. So let's just get right straight to it. So after you do the first two things, GCF and then check for special products, you're going to do factor by grouping. And I've given you a list of steps here, and it's going to be really confusing right now, but I'm going to read them anyway. First off, it says multiply the coefficient of the first and last terms. Second, find the factors of the number found in step 1 that add to the coefficient of the middle term. 3. Substitute the factors found in step 2 in place of the middle term. And then 4. Factor by grouping. Okay, what? Alright, so this is actually going to be easier if we work backwards, okay? Then we'll explain. So what we're going to do is we're going to start with step 4 first. We're going to pretend that we have done all steps 1 through 3 on factoring and all that stuff, and we're now down to the final little piece, so we need to do the actual grouping piece. And that's the way I want to do it. We're going to start with the end last, and then we're going to tell you how to get to the end. Alright, so I've given you this piece. 6x squared minus 8x plus 15x minus 20. Alright, so we have done everything. We've done all the little teeny tiny steps, and now we've got to do the factor by grouping. It's not as bad as it sounds, and again, I say that all the time, but it's true. Alright, so what I want you to realize is you want to group the first two terms and the second two terms together. So we're going to group these two terms together. Now, I want you to look at what I'm doing here. I don't just, in the second term, I am going to include the plus sign. If it was a minus sign, I would include the minus sign. There's a reason for it. Okay, so I've grouped this thing. Let me redraw that a little bit better. So I've grouped the first two terms, and I've grouped the second two terms. And now we need to remember that this plus means that this is a positive 15. Okay, so we've now grouped it. So what we're actually going to do is we're going to look at the first two terms, and guess what we get to do? We're going to basically do the same thing we've been doing before. We're going to do step 1, find the greatest common factor. Wait a minute, I've already done that. Yeah, that's true, but you get to do it again. Isn't that fun? Alright, so we're going to look at these first two. What is the greatest common factor that I can pull out of both of these two terms? Well, if you're looking at it, it's going to be 2x. So write it down. 2x, parentheses. Well, what will give me this? 2x times 3x will give me 6x squared. And then 2x times a minus 4 will give me a minus 8x. Alright, so we just factored. Basically, we've taken it, we grouped it, and then we're factoring it out. So we've done that first term. Okay? Now, we need to look at the second term. Well, what can I factor out now? Well, notice I have a plus here. So actually what I'm going to be factoring out is that sign. I'm going to factor out that positive, okay? So I know I'm going to factor out that guy. That's cool. All right, but what else do we notice? Well, I can factor out a 5 from this one and a 5 from this guy. So the highest I can factor out is a 5. Well, what does that leave me? Well, this is going to be 3x, because 5 plus positive 5 times 3x gives me that positive 15x. And this is going to give me a minus 4. Okay? Because we know that plus 5 times minus 4 gives me minus 20. Now, what did you notice? We've grouped two different things. This guy has 2x times 3x minus 4. And what's this guy say? Plus 5 times 3x minus 4. Well, what do they have in common? The first thing you need to realize, hey, they're both saying 3x minus 4. And guess what? You're almost done. Write that down. 3x minus 4. Put a parentheses around it. Okay? Now, here's the next part. These two guys that were left out in the open, they don't have any parentheses. They're lonely, they're sad. Guess what? They're going to get together and get married. And we're going to put a ring around them. Parentheses. What did I just do? I factored this guy through grouping. All right? I grouped the first two terms. I factored out the GCF, and I got this. Did the same thing over here, and I got this. I looked at what they had in common. The ones that were in common, I just automatically wrote them down instinctively. Just do it because I tell you to. Don't ask questions. Do you hear me? I'm talking to you. You know who I'm talking to. All right? Don't ask questions. You bring it down. And the guys that are remaining, they get hitched and become one binomial. So, how do we know this to be true? Does this equal this up here? Guess what we're going to do? Foil it. We're going to check to make sure we're right. 3x times 2x, what does that give us? 6x squared. Outer, 3x times 5 is going to give us plus 15x. Inner, minus 4 times 2x gives me minus 8x. Last, minus 4 times positive 5 gives me minus 20. Does this match my original expression? Yes, it does. The only thing that looks different is that these two terms are switched, but it's the same thing. It's okay. This does match that, so it works. Again, I've done all my steps all the way up to this point, and now I need to do my grouping by factoring. All right, so how do I do that? Well, I've got 4 terms, so I'm going to group my 2 terms here together. So we're going to group these two, and then I'm going to group these two. Now look again, I'm putting the group including the sign, this minus sign. It's very important that we start to do that. Okay? So we're doing this. So let's look at this first term. What do I want to do? I need to factor out the GCF of just these 2 terms. Okay? We're not worried about these 2 terms right now. We want these 2 terms. So what can go into both terms? Well, I know I can get a 2 because there's a 2 here. That's an even number. I also know that I can factor out a t because there's a t here and a t here. So what does that give me? Well, this will give me t plus, well, that's going to give me 5. How do I know this to be true? 2t times t, 2t squared. 2t times 5, 10t. Alright, so I'm done with this piece. Now let's look at this guy. Now, I like to do it this way first, and sometimes it gives you sometimes it messes up a little bit on you, but hopefully we won't see that. I like to factor out everything here. Like a while ago, I factored out the plus. I'm going to factor out the negative as well. So really what I'm going to do here is factor out negative 3. So that's what I just did. Now, can I factor out a t here? No, because there's no t here. So when I do, and I factor out the negative 3, what does this come? Just positive t. What does this become? Positive 5. How do we know this to be true? Well, negative 3 times t gives me minus 3t. Negative 3 times 5 gives me minus 15. All right, what do we notice that is the same since we've done the grouping part and we factored out what items are the same? Hey, the t and plus 5, that's the same. So I'm just going to automatically write that down. My two guys that are left on the outside, this one and this one, they're lonely, they're sad. They come together, they get a ring around them and get married. I have just factored this whole piece by grouping. We can work this out again. T, make sure we're right. Let's use FOIL method and see if we're right. T times 2t gives me 2t squared. Outer, t times minus 3, hey, minus 3t. Inner, 5 times 2t, hey, 10t. Last, t times, last 5 times negative 3, negative 15. Did this match this? Yes, it does. So we have factored this out completely. You know the drill, try it on your own. Alright, so in this particular one, when we factored this all the way out, we got y minus 6 times 6y plus 3. Now, this is actually cool, so this is technically right. Guess what? We can actually factor it just a little bit more. Check this out. What do you notice? 6y plus 3. What could we do to this guy? Hey, we could factor out a 3. So what we really could say is this. 3 times y minus 6, because of that guy, comes over here. We're factoring out a 3, which we're just going to put right there, is 2y plus 1. So if you got to this, that's cool, but you can factor it out a little bit more, which would have got you this. So just kind of be aware of that. Sometimes the problem asks you to simplify it completely in the most factored form or whatever, and you might get up to this part. But hey, you can do just a little bit more. So be very careful and very cautious of that. So all the way up until now, I've given you, basically have said that we have done all the individual pieces and we were on the last step of factoring by grouping. Now what we're going to do is actually do it for real. I'm going to give you an expression which is behind me, and our job is to factor it out completely. So the first thing I told you to do in this guy is when I give you an expression is to factor out the GCF. So look at each individual term. Is there a GCF? No. There's nothing in common. Alright? So the next thing I told you to do is to look for a special product rule. Does this follow a special product rule? Well, no. How did we know this? Well, all our special product rules, the very first term and the last term, were always going to be perfect squares. This is a perfect square, but is 10 a perfect square? No. So it does not follow our product rules, special product rules. So what do we do now? It's group by factoring. So let's kind of go back at our notes and I'll kind of give you what to do. First off, it says multiply the coefficients of the first and last term. So you got to need a little bit of scratch paper to do it. So I'm going to actually help do some things right here up on the side. So my first term, the coefficient of this is 1. Should be a given. My last term is 10. Alright, so what I'm going to do is multiply 1 times 10. And that gives me, this is my first step, it gives me the number 10. Alright? Look at step number 2. It says find the factors of the number found in step 1 that add to the coefficients of the middle term. Now, we can do this on paper, but I'm lazy. I'm going to show you how to do a calculator. So what I'm actually going to do is I'm going to make a funny face in this video, and I'm going to pause the video making this funny face, and we're going to cut to the dot cam. And I'm going to show you how to find those factors that I'm looking for. So I'm going to make a funny face now, and we're going to cut to the dot cam. Alright, so we already found what we're trying to factor by doing our first step. We took the first coefficient, multiplied it by last, and we got the number 10. So what we're going to try to do is find all the factors of 10. So the best way of doing this is going into your y equals button right here and type in 10 divided by x. Now, you're going to go to second table set, which is this right here. It's the second table set. And you want to make sure that your table is set up to be auto for your independent and your dependent. Now you want to go to second table, which is in this one. And now you have a nice little table, and what you see here are all the possible different factors of 10. Like I can have 1 times 10 gives me 10, 2 times 5, and then also give you some weird decimals, but the decimals we can skip. We just want to know the whole numbers. So our job right now is to find any possible factor that will add up to -7. So we know that 1 and 10 are factors, but do they add up to -7? No, they don't. They add up to 11. And we can do this one. The next one is 2 and 5, but that adds up to a +7. Well, knowing this, I can go up the direction and check this out. This one tells me I have factors of 10 are also -2 and -5. Well, -2 times 5 gives me 10. We already know that. But do they add up to -7? Yes, they do. So what's this tell us? We have factored 10 to what we need to be -2 and -5. So look at this next step 3. It says substitute the factors found in step 2 in place of the middle term. So this is really all you're going to do. You're going to rewrite the equation saying x squared. You're going to put minus 5x minus 2x plus 10. Why did I just do this? I put my 2 factors that I just found, and I put them in the place of this guy. Be cautious. Sometimes you might want to pay attention to what your first and your last term is, and where you want to place these 2 terms, because I could put the -2 here, or I could have put the -5 here, whatever. But you might want to be cautious of where you put it, because it can make your life either easier or harder when you go to group it. So just be aware and cautious of it. You'll see that as the more you do this. Alright, so now we've got to a part that we know how to do. So we've substituted the middle term. Guess what we're going to do? Factor by grouping. So I'm going to use the first 2 terms, the second 2 terms. What can I factor out of here? I can factor out of x. That gives me x minus 5. What can I factor out of this? I can factor out a -2. That gives me x minus 5 again. Alright, what do I do? The things that are the same are x minus 5. The things that are left over get married. And we have x minus 5 times x minus 2. Can we prove this? Of course, by double checking, by using FOIL method. Well, first, x times x is x squared. Alright, outer, x times this gives me minus 2x. There we go. Alright, inner, minus 5x. Last, positive 10. Did it match this? Yes. Does this, when added together and simplified, come back to this? Yes, it does, because minus 5x minus 2x gives me my minus 7x. So this all matches back up. Alright, same procedure. We are going to simplify this, or factor it into its most simple form. Okay, so first step, factor out any GCF. Do we have one? In this particular case, again, we don't. We don't have a GCF. The next thing we need to look for is, does it follow our special product rules? Nope. Alright, so what's next? Group by factoring. So we give you a little set of steps again to help. So the first thing that we need to do in order to make sure we can factor this bad boy is we want to take the first coefficient and multiply it by the last coefficient here. And so we're going to say 7 times -2 gives me -14. That's our first step. So the next thing that we have to do is find out the factors of -14 and find out which one of those factors that when they add together are going to give me -13. Now some of you probably can think of that in your head, but I'm going to make another funny face and we're going to cut to the calculator and we're going to show it to you. So we just discovered that when we multiplied the first coefficient by the last, we got -14. So we're trying to find all the possible factors of -14 that will add up to -13. So we're going to do just like we did last time. We're going to go into y equals, and this time we're going to put in -14 divided by x. And since I've already got my calculator set up where I want it to, I'm going to just go ahead and set second graph. Alright, so now we've got some things going on here. And well, look at this. Right off the bat, it says 1 and negative 14. We know that 1 times negative 14 is negative 14, and we also can tell that 1 plus negative 14 happens to be negative 13. So our factors are negative 14 and 1. Alright, so what we've discovered is that we can do minus 14 and positive 1 as our factors for this. So now that we know our factors, we can plug these factors in place of our middle term. So we can say 7x to the 4th. And this is where I was telling you earlier, you might want to really pay attention to which term you put in whatever place. I could put the plus 1 here and we could probably solve it, but notice this is a minus 14, and what could I do? Hey, I could put it along with the 7s because I know I can factor out a 7 later and make it nice and easy for me. So I'm going to actually put the minus 14 x squared here, and now I'm going to put the plus 1x squared minus 2. Okay, so I've done the two terms, and now I'm going to just do like my normal thing, factoring by grouping. So we do it. Well, what can I factor out here? I know I can factor out a 7. I know I can factor out the x squared. That gives me x squared minus 2. Alright? Look at what we've got here. It says x plus 1x squared minus 2. Wait a minute. This is weird. So what can I factor out? Guess what? I can factor out the plus 1. Okay? Sometimes that happens. Sometimes you're going to have to factor out the 1. You may not see it at first, but you're factoring out the 1. You also might be factoring out a negative 1. So just be aware of that. So I'm going to factor out the plus 1, and I get x squared minus 2. What happens? Well, things that are like get written down. Things that are outside on their own, they get married. And there we go. Now, a lot of times we get to this part and we say, hey, I'm done. But just in case, double check, okay? And see, could it possibly be factored out even more? Because this looks kind of strange. Do you know what it reminded me of when I first looked at it? A difference in squares. Well, is this a difference in squares? No, it's not. It's not. Because this should have, if in order for it to be so, it would have been like saying x squared minus 4. So this isn't a difference in squares. Does this follow any special product rules? No, it's not. So we factored this as low as we possibly can. But just remember, just because you got to a certain point doesn't mean you're always through. Always double check what you've got to see if you can factor it even farther. And you'll see some problems like that here very soon. Alright, you know the drill. Pause the video, do the 2 on your own, come back, see how you did. For your first problem, you should have saw that your factors would have been 11 and 3, so this would have become your middle term. Once you completely finish your factor by grouping, you would have got x plus 3 times x plus 11. Alright, for the next one, you should have probably seen that your middle terms would have become minus 15x squared plus 1x squared. Factor all this out, you should have got 3x plus 1 times x squared minus 5. Alright, we have left in your notes 6 different problems. I'm going to go ahead and tell you, I want you to please try these on your own. Before you go watching the rest of this video, I am going to explain each one, but I want you to try these 6 first. So pause the video, please try these 6 and see how you did and see where your mistakes may have lied. If you're just watching the video from here on out, you're not learning anything. So please, 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 please follow those rules. Factor out the GCF first. See if there is any special product rules that you can use, and after that go after your grouping by factoring. Okay, all of these can be factored. Okay, so you should get to a simplified form in some way or somehow. But what I've done in all 6 of these is different things. Some of them are a doozy. Some of them they're just throwing at you. You're just not expecting it. But it's basically all the little rules that we've done up to this point, and I'm combining them all. So please, 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 I'm begging, please, please, please pause the video, try these on your own, and don't just wait for me to give you the answers. I bet you didn't pause. You better pause now. Okay, now we're back. Alright, so 2s squared minus 10s plus 8. So what we want to do is factor this thing. So let's start off. Factor out the greatest common factor. Well, what do we see? The coefficients, I can factor out a 2 out of each one. So I'm going to just write that down. Okay, so I'm going to write that down. Can I factor out an s from each one? No. So the greatest common factor that I currently have is just 2. So when I do that, that's going to give me s squared minus 5s plus 4. Okay, sorry that my s's and my 5's look similar. So I have s squared minus 5s plus 4. Alright, so now we need to look at this thing. And we've done the GCF. We need to ask ourselves, is this a special product rule? Well, the one way that we can determine that is by looking at the first and the last terms. If the first term and the last term both happen to be perfect squares, it's highly possible, notice I said possible, that this is a special product rule. So let's look at it. Well, what do we have here? We have a square here. Yep, so that'll work. We have a square here. Yep, that will work. Alright, so is it possible that this might be a special product rule? So let's look at it. If it is, we notice that we have a plus. Oh, this reminds me of the square of differences. So it's quite possible that this might be s minus 2 times s minus 2. And you may have saw that and you may have stopped. But here's the problem. You probably didn't check it. So let's check this thing, and because it's very similar to what we've talked about. It's very similar to the sum of differences, and so this would have actually gotten, if we did it like this, it would give us this s squared minus, well, this right here is going to give me 2 minus 4s squared plus 4. Did this work? No. So the special product rule that we thought might have worked doesn't. So what does that tell us? Well, this part is not correct. So what do we need to do? We need to go on to the next piece, which is grouping. Alright, so I'm going to erase this. So we need to ask, how do we do this? Well, our grouping procedure tells us to multiply the first coefficient by the last. That's going to give me a positive 4. Alright, so I need to find out all the possible factors that will get that. Now, I've done this multiple times, so I know that I can say this. 2 times s squared minus 4s minus 1s plus 4. How do I know this? Well, minus 4 times a minus 4 gives me the positive 4 I need. That's the factor. I also know that when I add these two together, I'm going to get minus 5s. So I just did the 1, 2, and 3 for you of the group factoring. Okay, so you should have been able to get up to this point. Now, what do we do? Well, we're going to factor. We're going to factor this piece and this piece. Well, what can I pull out of here? I can pull out an s. Alright, and that's going to give me s minus 4. Well, what can I pull out of this one? I can pull out a minus 1. What's that give me? S minus 4 again. So what happens? Well, my s minus 4, we're just going to write that down just like I told you before. Sorry, it does look like a 5. That's s minus 4. And now what's left over is the s minus 1. That's left over. So if you got to this part, and this is where you stop, there was something that you forgot. Can you guess it? This guy. You remember how I told you at the very first video, factoring is not division. Things don't just disappear. Whatever we factor out, we have to keep. So what happened? This 2 technically came down in each individual step. We never really got rid of it. I just stopped writing it. More than likely, you did too. And because of you stopped writing it, you probably forgot to put it in your final answer. That is a very common mistake. So don't forget that first thing, that greatest common factor, he's still going to be in your final answer. It's not going to just go away. So ultimately, we find out when we factor this out, it's going to be 2 times s minus 4 times s minus 1. Can we prove this again? Yes, we can. Guess what I'm going to make you do? Check it. How do we check it? Well, full method at first. S times s gives me s squared. S times 1 gives me minus s. Okay? Minus 4 times s gives me minus 4s. Minus 4 times minus 1 gives me that. Alright, well what happens with these two things? They give me the minus 5s. I got to put my 2 back into it and multiply it. Guess what? I've worked it all the way back up to the top. Now I could have done that all by hand, but you can see how this works backwards. Alright, so big take from this. 1, just because something looks like a special product doesn't mean it is. Because it kind of followed my advice, but we had to double check it. Remember we did that a while ago, and it did. So this was not a special product. So we had to do grouping by factor by grouping, work it all the way out, and don't forget whatever you factored out at the very beginning, you need to also keep at the very end. It doesn't just go poof. All right. So let's try the next one. 16x squared plus 144. Alright, first thing, factor out a GCF. Can I factor out of this? Well, I can do multiple things. I can go 1, 2, 3, 4, blah, 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 and keep on going, but I'm going to save you the time. The greatest common factor that I can factor out currently is a 16. When I do, that gives me x squared plus 9. Alright, so now that we have factored out the greatest common factor, what's the next step? Check to see if that's a special product. Well, look at this guy. I have a perfect square here and a perfect square there. So it looks like it would be. However, you need to go back and look at those those special products. There was only one special product that I gave you that had only 2 terms, and it was this: a squared minus b squared. See that? That's the difference between this guy. This is an addition. This is not. So what is this telling me? This is not a special product. So guess what? I can't do anything else with this thing. I've gone as far as I can. This now is what we would call prime. It's been factored as low as I can factor it. We now have 4x squared minus 36xy plus 81y squared. Say that in one breath. That's kind of tough. Alright, now, the first instinct you should be doing is greatest common factor. Is there a greatest common factor in all this? Your answer is no, there isn't. The coefficients, there's nothing in the coefficients, and there's nothing that we can do for the variables. So the second thing that you need to be doing is it a special product? I've kind of helped you out with special product before, but think about it. How can you tell? Well, you need to look at your first term and you need to look at your last term. Is your first term a perfect square? Yes, because this is a perfect square and we can make this into 2x when we square root it. Is your last term a perfect square? Hey, yes it is. So what does that mean? It means that there is a distinct possibility that this is a special product. However, we need to check it to see if it's true. So let's find out. We know that this is going to give me 2x when we square root it. Right? So we get that. We know that this, when I square root it, is going to give me 9y. So we've got our two terms, our two things going on here. The question is, what do we put there? Do we put minuses, pluses, or both? Okay. So let's go back and look at those special product rules. There's only 2 of those rules that have 3 terms in it. One is the square of differences, and the other one is the square of sums. And I'm going to pause the video and come right back. Alright, so where was I? Anyway, what we actually were talking about a while ago was that there were the special product rules, there were two special product rules that talk about three terms like this one, okay? One was the square of sums and the other one is the square of differences. All right, so if you looked at them and you notice there's a pattern, the square of sums, this middle term, this would have been a positive number, okay? Not a negative like it is. So what it's telling me is that this is going to probably be my square of differences. All right, so this is what we're probably going to use for our special product rule. However, we don't just need to assume that this is correct. I showed you before that when we assumed it and we actually checked it, it was wrong. So we need to double check this thing and see if it works. How do we do it? FOIL it. 2x gives me 4x squared. That was my first. Now I'm going to do my outer. So 2x minus 9y, that gives me minus 18xy. Now I'm going to do my inner. Multiply these two terms. I get minus 18xy again. I'm going to do my last of my terms, and I'm going to get plus 81y squared. Well, what happens now? These two terms get combined. Guess what I get? Minus 36xy. So does this check? Yes, it does. This term times this multiplied to get this, and ultimately we simplify this to get back to our original expression. So this first term factored out is 2x minus 9y times 2x minus 9y, and for those of you who want another way of saying it, you could say 2x minus 9y squared. Now we have 6n squared minus 39n minus 21. So instinct, GCF, coefficients first. Is there anything that I can factor out of each and every one of these things? Yes, there is. We can actually factor out the number 3. That is that. Can I factor out also a variable of some sort? There's an n here, but there's not one here. So our greatest common factor that we can use currently is just 3. So let's go ahead and simplify things out. When I factor this out, that gives me 2n squared, because this times that gives me this, minus 13n minus 7. All right? So now we have this. 3 times 2n squared minus 13n minus 7. Alright, so the question is, does this follow my special product rules? So look at the first and your last terms. Is this a perfect square? Nope. So let's stop. This is not a perfect square, so it is not a special product rule. So what do? We need to start looking at factoring by grouping and seeing if that can work. So guess what? I'm now going to do my special funny face and cut to the dot cam and see what we can find. Alright, so we just did in the video that we were going to do the first coefficient by the last, and that gives us negative 14. We already actually have this, believe it or not, set up from our previous thing. We wanted to find the factors of negative 14, so negative 14 divided by x. We're going to check our table, and since our middle term was negative 13, we're actually going to use the exact same thing we did in our previous clips. We're going to use the factors of 1 and negative 14. Alright, so after doing my funny face, I found out that when I multiplied my first coefficient by my last coefficient, I got negative 14. Okay? And now what we do is we went and found those different factors. We found out that minus 14 and plus 1 are going to be our middle term. So we're going to do that. Now, let's not forget our 3 is still here, okay? So we're going to put that there. So now we're going to say 2n squared. And I'm going to put minus 14. Why am I putting the minus 14 here? Well, because that's an even number. And this is the number 2. And I'm going to factor out 2 later. Okay? Minus 14n plus 1n minus 7. Okay? Now, we're going to factor by grouping by using these two terms. And we're going to factor out these two terms. Well, I don't want to forget that 3, okay? I don't want to forget it. I'm going to keep writing him down so I don't lose him. Alright, this is going to be factored out by 2n. And that's going to give me n minus 7. I'm going to factor this out by positive 1, or plus 1. And I get n minus 7 again. So what am I going to write? Well, I don't want to forget my 3 because that's what my GCF was at the very beginning, so we can't lose that guy. And we're going to write down what we have in common, n minus 7. And then we're going to, whatever's left, we're going to marry them, get them married, and put them together. And so this one, when factored out, should equal to this. 3 times n minus 7 times 2n plus 1. Now before I take it any farther and go and double check, can I do any more factor with any of this? No, this is as far as I can currently take it. Alright, so we need to double check to see if this is right. So what we do is we FOIL this. N times 2n gives me 2n squared. Minus 7 gives me all this. I end up getting minus 14n. I do the next piece, plus 1n, and so did that work? Does my FOIL method get me to this point? Yes, it does. Well, does this get me back to here? Yep, sure does. And since I've got that 3, and I've got the 3 here, does this get me back to the top? Yes, so we've double checked it. Alright, so let's go on to the next problem. 3a squared c squared minus 6ac plus 3. GCF it, find it out first. So what can I factor out? I can factor out a 3 out of everything. Can I factor out any of the variables? No. So what does that give me? 3 times a squared c squared minus 2ac plus 1. Alright, so that's the first thing that we have. Now, go into the next thing, special product rule. Is this a special product? How can we tell? Well, look at the first term. Is this a perfect square? Hey, yes it is. Look at the last term. Is this a perfect square? Hey, yes it is. Wait a minute, so there is a possibility that this is a special product rule. So I could be possibly saying 3, because we don't want to forget it. Well, the square root of this guy is going to be AC. So we're going to write that down. And the square root of this guy is 1. Right? Now, the question is, since this was a 3-term polynomial, which one of our special products rules does it use? Well, there was only 2, like I said before. There's a square of differences and a square of sums. How can we tell the difference? It's by the middle term. The square of sums, the middle term would have been positive. The square of differences, the middle term is negative. So it is quite possible that our factorization is this. 3 times AC minus 1 times AC minus 1. So you're probably like, oh, let's just stop and move on from there. But we're not. We need to double check to see if this can get us back to this. So how do we do it? FOIL it. AC times AC, because we're going to do FOIL method, is going to give me A squared C squared. I'm going to do my outer, which is going to give me minus AC. I'm going to do my inner, which gives me minus AC again. I'm going to do my last, which gives me plus 1. Alright, and I'm going to put that in parentheses because I don't want to forget my 3 over here. Okay, well, I'm going to work this all the way out. It's going to give me A squared C squared minus 2AC plus 1. Well, does this look familiar? Yes, it does. It looks just like this guy right up here. So do we know that this and this are the same? Yes. And since we already know that this will equal to that, we know that we're correct. So just because you have made the assumption that it is a special product like we see here, doesn't always make sure you're right by really doing that double check. Here is our last problem of the video. 15x squared minus 39x cubed plus 18x to the 4th. Alright, GCF this thing. Let's find out what happens. According to our coefficients, what can we do? I know out of all of these, I can factor out a 3. So I'm going to write a 3 down. Okay, so I can factor out a 3. Can I do anything else? Well, notice that all of these have x's in them. This has, how many x's are in this one? We have 2. How many are in this one? We have 3. How many are in this one? We have 4 x's in this one. So what can I really do? I can actually factor out 2 x's this time instead of just 1. We've been only doing like maybe 1 variable or something like that. This time I can actually factor out 2 x's, or in other words, I could factor out an x squared. So when I do that, what happens? Well, this will become 5, because 3x squared times 5 gives me 15x squared, so we know we can factor that out to be a 5. Minus 13x. Well, does this work? This times this, does it give me minus 39x squared? Cubed? Yes, it does. 3x squared times a negative 13x gives me minus 39x cubed. Now we're going to do this part. What happens? I'm going to get plus 6x squared. Alright. So, did this work? Yes, it worked. So we're good to go on this. So we have factored it out. Now, this is where you might be scratching your head like, well, this is not everything in the right order. It's and you know what? That's okay. We can actually rewrite this to make our life a little bit more saner. We don't like it this way. We like things in numerical order. So I'm going to rewrite this piece again to make our life just feel better. So we don't need to forget our GCF, and we're going to rewrite this as 6x squared minus 13x plus 5. Alright, cool. So let's look at this guy. We've got it all nice and organized for us, and it makes our lives nice. Okay, so does this follow a special product? Well, ask yourself, is this a perfect square? Nope. So if this is not a perfect square, it's not a special product, so I'm not going to waste my time. Alright, so what it does tell me is I'm going to have to make a funny face and see if I can group this by factoring. So what am I going to do? My first step is to multiply these two numbers, the coefficients of these two, and I find out that I get 30. Now, because I don't want to make a funny face right now, I'm going to go ahead and do on to this next part. I need to find what factors could possibly get me, when multiplied, give me 30, but when added together, give me negative 13. Well, I can help you out on that one. Negative 3 and negative 10. How did I know that? One, I've been doing this a long time. What if I didn't know how to do it? Well, do what I've been showing you with the calculators. Okay? Do that. Now, we've done this, so I'm going to plug this back into all of this. So we have 3x squared times 6x squared minus, I'm going to put minus 3x because I can factor out a 3 later on, minus 3x minus 10x plus 5. Okay, so I'm going to go ahead and group these things together like so. And I'm going to say 3x, and we'll just keep writing that, guys, so I don't forget it. And this is going to be 3x times 2 minus 1. That's 2x, excuse me, 2x minus 1. And this is going to be, I'm going to factor out. In this case, look at this one. If I factor out, I can factor out a 2 or a negative 2 or whatever, excuse me, not 2 but 5. What I really want to do in this case is to factor out a negative 5 because I don't like that negative. So I'm going to factor out a negative 5 here, and that gives me 2x minus 1. What do? Well, my GCF comes on down. What's in common gets written, so it's 2x minus 1. What my leftover guys, which are 3x and the minus 5, they get hitched and married together. And I have my factorization. 3x squared times 2x minus 1 times 3x minus 5. Again, can we prove this? Foil! This times this will give me 6x squared. Then I'm going to do my outer, 2x times minus 5, negative 10x. This times this gives me negative 3x. Negative 1 times negative 5 gives me positive 5. So I just went back to this step here. And I know that when I work this backwards, it's going to get me all the way back to my original equation. So that's the end of this video. My son is screaming, so we're going to actually stop the video now.